Greetings. Today we're going to do our second part of producer theory. This is the background behind some of the market economics that we'll be looking at in this series of videos. This one we're going to be looking at revenues, costs, and profit and how they're related to the production function that we introduced in the last chapter. So as a quick summary, the production function describes the inputs, technology, and outputs created for any given production process. In this case, we're going to stylize it and simplify it down to a two-input product. So for example, it'll look something like this one right here. So Q is equal to a function of capital and labor. So Q is our output. This is the F stands for the functional relationship, or how the two input variables are related. And our two input variables are capital and labor. So this describes the combination of capital and labor that is used to produce any given quantity of output Q. And so that's kind of where we begin, just as a summary from last time. So the production function, we can use that to derive many of the economic measures of relevance that we care about. For example, where we're going to start is looking at how we transform the production function into revenue, which is one of the key things if you're a business that you care about. So once the product Q or output is made, it's intended to be sold, and that's the whole point of the firm. So the revenue the firm receives is income, and it's described as total revenue, TR, is equal to the price that you receive per unit times how many units you sell. So as we're looking at the revenue function, so we start out with the production function up here. Q is a function of K and L, and from this we can derive total revenue. And so if you look at the production function, or if you look at total revenue right here, what we see is that the production function is embedded by the nature of using the level Q output in the total revenue here. So two other measures that we look at that are derived from the total revenue are going to be the average revenue, which is simply the total revenue divided by your output Q. We then have marginal revenue. Marginal revenue describes the additional revenue that it will be received from selling one more unit of the input. So if we're looking at calculus, that's going to be the partial of total revenue with respect to the partial of your output Q. If we're looking at discrete terms and not continuous, we can look at delta, which means the change. So we have the change in total revenue divided by the change in quantity, tells us how much revenue we're going to get from selling one more unit of the good. So another way to simplify that algebraically is to look at 2 points of total revenue, so total revenue 2 minus total revenue 1, and subtract Q2 minus Q1, and that'll tell you how much additional revenue you're getting for every unit that you sell at that point along the total revenue curve. So we can do the same type of thing in relating to costs. So we can take the production function, and one of its main uses is to also derive costs. And costs, of course, are going to determine a lot about how much profit the firm is making. So we care both about revenues, as we saw in the last slide, and we also care about total cost. So total cost is the cost to produce each unit, so the C of Q. This defines so C stands for cost, and Q is for any given level of output Q, how much is it going to cost to produce that level of output? And then if you take, so total cost is simply how much it costs per unit, which is the C of Q, times how many units you produce. So this cost function C of Q is a function of our variable inputs K and L. So if we allow, and so we can rewrite C of Q to be equal to C of K and L, because we let Q equal to the right-hand side F of K and L. So here we see that our cost function and the technology and the relationship between capital and labor and our variable inputs and our fixed inputs determine how much it's going to cost us per unit to make any given level, or how much it's going to cost us to produce any given level of output. And so that production function is absolutely embedded in our cost function. Okay, and so we're C of Q. Now what we have right here is we have the function C of Q, which remember can be written as C of K and L, is related to, if we simplify that a little bit with our two-input model, I'm looking right here. So capital is the total amount of capital that we're using. L is the total amount of labor that we're using in order to produce this level of Q. R is the rental price of capital. That's how much that capital is going to cost us is the interest rate R. And then how much that labor is going to cost us is the wage rate W. So to find a total cost function, we simply have how much K we need to use, how much L we need to use, times their respective prices. The amount of K and L that we use comes from the production function. So on our next slide, we can do the same type of thing that we did for revenues. So we start off with the production function up here. Q is equal to F of K and L. We derive our total cost function, which is a function of the amounts of K and L that we use that are derived directly from the production function, time their respective prices. From that we can then define the average cost, and an average is simple the total divided by the quantity. the total number that we have. The marginal cost is exactly the same as the marginal revenue, which is to say that we take the partial of total cost with respect to Q, and what that's going to tell us in a continuous space is that how much is our cost going to be increased for every additional unit that we produce. So if we produce one more unit of the good, how much is our cost going to change? And so we can rewrite that in discrete terms where we have delta total cost divided by delta Q, and that really just stands for the change. So what is the change in total cost attributed with the change in output? And so this is the continuous form right here, and this is the discrete form right here. If we're looking algebraically in discrete terms, and if we have a table of cost values, for example, we could take any 2 points, TC2 and TC1, that are sequential, and we can subtract the second one from the first one, do the same for the respective quantity values, and it will tell us the additional cost or marginal cost that's associated with producing one more unit of the output. Now, in economics, if you remember, just as a quick point, when we're trying to find how to optimize things, or we're trying to look at the best way to do something, we're really looking at these marginal values because we want to look on the edge for the next decision that we have to make, or for the next thing that we have to do. What is the best thing that we're going to do? So we always want to find, in this case, what we're looking at is trying to find the minimum cost and the maximum revenue or the maximum profit. So we want the greatest benefit for the lowest cost, and that's where we're going to find the optimal solution to any of our problems. And we do that using these marginal values because it tells us for the next decision that we need to make, what is the benefit and what is the cost. And that's really our fundamental decision rule that runs through every single model in economics, and it doesn't really matter what we're looking at. At the end of the day, the tool is the same. You're looking at the marginal benefit, you're comparing it to the marginal cost. And as a very, very simple rule, and if you just remember this, it will simplify pretty much all of economics for you, is that we're always setting the marginal benefit equal to the marginal cost. Sorry, that was supposed to be an M. So the marginal benefit equal to the marginal cost is our optimizing rule. And so you can conceive any problem in economics or any problem in life pretty much. You can recast it in terms of these benefit functions and these cost functions. And if we look at the edge where we're trying to say, well, what happens next? And if we look at what happens next if we do one more unit, one more activity, one more whatever, and we look at the marginal benefit versus the marginal cost, that's where we're going to have the best that we can possibly do. And that's really every rule in economics summarized right there. So for our next slide, I wanted to show just a little bit more of how we kind of go from a production function into what you're normally going to see when you're trying to do the optimizing decision rule. So again, the total cost is a budget constraint for the firm, and it defines the total cost for any given level of output. So if we have a two input type of production, as epitomized by what we did with the total cost, being a function of capital and labor and the prices R and W, you'll notice that in this context, this is just the equation of a line. So we can rearrange it, and it's really just a rewriting of the y equals mx plus b. And so we're going to have a slope, which is the m, we're going to have our horizontal axis, and we're going to have our vertical axis. Remember, the b is the vertical intercept. The x is going to be what point down here you are on your horizontal axis, and your m is the relationship between the two, and that's going to give you any point along the line. So we can rewrite this here because we know that k is the same thing as y, so that's our vertical axis, and then we know that L down here is our horizontal axis. And so we can simply do a little bit of algebra and rearrange this so that we have the total cost divided by R minus W divided by R times L. And so this one right here, W over R, negative W over R, is in fact the slope of this line right here. So the slope of that line is negative W over R, and that tells us the rate at which we trade, how much it's going to cost us to trade one more unit of capital for one more unit of labor. And so that's our equation of a line, and we can always rearrange from a total cost function to this one, and if it's linear, it's very easy. If it's not, you got to do some calculus. So now, if this is our production function, Q, and we can have a whole series of these Q's, right? We can go Q1, Q0, Q2, on out from, in this case, a ray that goes out from the origin. And where our budget lines intersect or are tangent to, where our budget lines are tangent to our production functions, are where we have our cost minimizing use of capital and labor. And so these points right here, any place where this line is tangent to this arc, is where you're going to be able to do the best that you can. And when we minimize costs, we're also going to be maximizing profit. So this is the point that you always want to look for. So in practical terms, what you're going to do is you're going to set your production function equal to the cost. And so if you have some sort of equation here or some value here, and you have an equation here, all you have to do is set them equal to each other and then solve for whichever variables you're looking for. So at the end of the day, it's actually somewhat straightforward if you keep in mind what it is you're trying to do. Okay, so the next one, now that we've kind of gone through revenue and we've gone through profit, we would now want to look at how we go from, or we went from revenues to costs, we want to look at profit. So profit, remember, is the thing that we really care about. And so profit is just the sum of how much we've earned, which is our total revenue, minus how much it cost us to do it. Anything that's left over is profit. And so this is the entire objective of the firm, and the only reason the firm exists is to produce this profit. And so to understand if your firm is making a profit, you need to be able to calculate your total revenues and your total costs, and they're always given for any given level of output. And your profit is going to change depending on how much you're producing, because we have diminishing laws of returns and some other things where the more you, remember we're talking about the marginal benefit and marginal productivity, so the more you use of capital, the more you use of labor, you're going to get less and less output and less benefit from each unit that you use. So therefore, you have to find what level of output maximizes profit. And so that's really the entire objective of the firm, is to figure out, given technology, given input prices, how much are you going to produce in order to maximize profit right here. So one of the things to keep in mind about this, and this is pretty much where we'll end this for today, is that in economics, profit is a little bit different than it is in the accounting sense. So in the accounting sense, the entrepreneurial effort and the return on capital is not included in what they consider to be profit. So theirs are just pretty much what you would think of as straight up costs and straight up revenues. So their costs differ from what we consider in economics. And so you can have a positive accounting profit and a zero or negative economic profit because of the return on capital and the opportunity cost that's embedded with the return on capital. So one of the key things I want you to take away from this is that profit is dependent on technology, factor markets, and consumer markets. And so it all has to come together in order to understand whether the firm is going to make profit, and those things change depending on what's changing in the environment. So one thing that I hope that you're kind of beginning to see from the way I'm presenting this material is that the economists, we use the same set of tools. So we have the same equations and the same models, and we basically have the same graphs. And so we're able to use a very simple framework where you don't have to know that much math. It's relatively 3 or 4 things that you need to learn, and then all we're doing is relabeling things. So if you can kind of look through the messy details and see the bigger pattern, you'll know how to solve any given problem because it's all the same. We set one equation equal to the other and we find the marginals, and that's all we're doing. And so some of the work that you'll be doing kind of helps you walk through that, but I think having the bigger picture hopefully helps you understand that a little bit. And so that's it for this one. Thank you very much.